Okay, I will record the video and I will upload it later. So let me start. So this is revision for DSP, digital signal processing. We'll revise chapter 1, chapter 2, and chapter 3. The chapters which are included in your final exam. So is the sound okay? So let me continue. So let's revise first chapter 1. We'll see some review questions. So question number 1, it says list the advantage of digital signal processing. As you know, there is analog signal processing and digital signal processing. Digital signal processing provides advantage when you compare it with analog signal processing. So what first advantage of digital signal processing is accuracy. Accuracy, which means, as you know, digital signal processing, we use a digital processor like computer, microprocessor, and so on to process our signal. We are not using electronic components here. So, for example, if you take a resistor value R depends on temperature, right? So if you construct analog circuit using resistor, capacitor, and so on, this analog circuits, they are dependent on external factors like temperature, vibration, and so on. In addition to that, it is very susceptible to external noise. So analog signal processing is not accurate. But when you come to DSP, digital signal processing, we are using a processor with a program, so which is not affected by external factors like temperature and so on. So we have a more accurate result from DSP when you compare it with ASP. So that's one advantage of digital signal processing, accuracy. Second, digital signal processing, DSP, is more flexible compared with, so when you compare the analog signal processing, we are comparing here the old analog signal processing technique with the new digital signal processing. These days, as you know, almost all systems go to the digital, which means digital signal processing provides more advantage when you compare it with the older one, which is analog signal processing. Okay. So first advantage when you compare digital signal processing with analog signal processing is, as we have discussed, it is DSP is more accurate compared with analog case, because the analog circuits, we construct analog circuits to process signal using electronic components like okay, more students are coming, so is the sound okay? Please check the sound. Can you hear me? Okay. Thank you, Sagaria. He said you can hear me. So today, what we are going to do, we'll see some review questions. Review questions from chapter 1, which is the introduction chapter, introduction to DSP. We'll see some review questions. Chapter 2, the time domain analysis of discrete time systems and signals. We'll see some review questions. And chapter 3, which is the transform domain analysis. Particularly, we have discussed Z transform, or generally you can say transform domain analysis in DSP. So these 3 chapters are included in your final exam. So here I am trying to revise these 3 chapters using some review questions. So let's start again. Chapter 1, introduction to DSP. So let's see the first review question. Here we are asked to list the advantage of DSP, digital signal processing. Okay. Similarly, here you see in equation 2, part A, it says compare analog signal processing, ASP, and digital signal processing, DSP. So you have to revise this from chapter. What is the difference between ASP, analog signal processing, and digital signal processing? Compare the two. Okay. So when you compare advantage of DSP, ASP is the older version, analog signal processing. So in ASP, we use electronic components like resistor, capacitor, and so on. Capacitor, inductor, right? Transformer, and so on. So using these components, we construct a circuit, analog system, which is used to process a signal. Processing means, as we have discussed, it means storing the signal, it means transmitting signal, it means enhance the quality of signal, and so on. So processing, without processing of signal, there is no telecommunication, there is no electrical signal. We need to process our signals. There are 2 ways of processing a signal. First method the older version, analog signal processing. So, in order to process our signal, we construct circuit, right? We construct circuit using these basic components like resistor and so on. This circuit is used to process our signal in analog way. We call it analog signal processing. Now in this in the analog signal processing case, because we use these electronic components like resistor, if you take for example a resistor, one of very common device in analog circuits, resistance of a resistor depends on what? Depends on temperature. Depends on temperature. So the circuit, the analog system is not accuracy. I'm comparing accuracy. Analog systems, analog signal processing is not accurate because these components depends on external factors like temperature and so on, right? So when you come to DSP, digital signal processing, we are not using these electronic components. We use our computer, our processor, right? Our computer or any other digital processor together with some kind of program. For what purpose? For processing our signal. So compare now ISP and this DSP in terms of accuracy. Which one is more accurate? DSP is more accurate because it does not depend on like temperature and any other factor. Noise. If you have external noise, your analog circuit will be susceptible. Okay, but digital systems are more accurate when you compare with analog circuits. So if you are asked what is the first advantage of DSP, it is what? Accuracy. Okay, so DSP is more accurate in signal processing compared with ASP, analog signal processing. Second advantage is flexibility. What does it mean by flexibility? In analog circuits, if you want to change some parameters, you have to change the components, right? But when you come to DSP, we are not using this electronic circuit. We are using computer with what? With a program. So if you want to change your parameter of your system, simply go and change some variables, some parameters on the software, on the program. We don't need to replace components. We don't need to design again our circuits and so on. So when you compare SP and DSP, again DSP is more flexible. Okay, it is more flexible compared with analog circuits. In signal processing, DSP is more flexible compared with analog signal processing. Again, another advantage is it's easy. DSP is easy because we are using computer with a program. You can easily solve difficult mathematical functions. Okay. Difficult equations. In engineering, as you know, mathematics is our language, so there are many mathematical equations. So it's very difficult to solve these mathematical equations using a circuit. It's very difficult design process. But as you know, these very fast computers these days, with so many applications and programs, it's very easy to solve these difficult mathematical equations or functions in engineering. So for operation, which one is easy? Again, DSP is very easy compared with analog signal processing. Next, in terms of cost also, these days there is a technology called VLSI. VLSI, which means very large scale integration. So you can see now these days high speed processors in small size. Okay, so because of very small, very large scale integration, VLSI technology, these days the price of these processors, computers, is going down. These days you can buy very high speed computer with less amount of money. So if you compare the cost to construct a circuit for processing a signal, compare with DSP, DSP again provides us a lower cost. So here I mentioned some of the advantages of digital signal processing. I'm comparing also analog signal processing and digital signal processing. Okay, question 2, part B. It says draw block diagram of DSP. As you can see here, this is a block diagram of a digital signal processing. So always DSP takes analog signal. This analog signal, first here we have a pre-filter, okay, pre-filter device. Then the next is analog to digital converter. So this analog signal will be converted into digital. Why? Because the processor here, computer or microprocessor, any digital processor, it only accepts digital data. So first our analog signal must be converted into zeros and ones. Okay. Then after processed by your computer also generates a 0 and 1 data. Then this 0 and 1 data must be converted back into analog by a device called digital to analog converter. So this is simple block diagram of a DSP system. So if you are asked to draw a DSP block diagram, and explain, not only draw, you need to explain what this block diagram means. This is simple block diagram of a DSP system. So what is PRF? It is called pre-filter. You can take note. I will also upload this video later. POF means post filter. Post filter. So pre-filter removes some. It is called also anti-aliasing filter. Before the analog to digital converter, we have to use a anti-aliasing filter. Then this, after removing this unwanted frequency components from the analog signal, the next device is analog to digital converter, which converts this analog signal, okay, analog signal into digital data, zeros and ones, which is not processed. This is unprocessed data. Then we need to use a computer here or any type of digital processor This signal is processed, and here we have a processed data, okay, zeros and ones. This is unprocessed data. This one is processed data. After processing, this is a digital signal. We need to convert it back into analog form by a device called digital to analog converter. Again, here we have analog signal, but which is what? Which is processed. After processing, we have our signal here in the form of analog. Here we have analog signal before processing, which is unprocessed signal. Unprocessed signal, they are useless, right? These days, unprocessed signals are useless. So this unprocessed signal must be processed by a digital processor here. Here we have a post filter. When this digital to analog converter convert binary into analog, it's not smooth. So we need a filter called post filter, which is used for smoothing purpose. Smoothing filter, also you can call it a smoothing filter. Okay, smoothing filter. So if you have any question on question number 1 and question number 2, you can ask. Any question? If you have any question, please write on the chat section. Is it clear? I mean, okay, thank you very much. So let's continue. Okay, from chapter 2. Here we are asked to sketch unit step sequence. Please revise the basic elementary discrete time signals in chapter 2. What is the first signal? It is unit impulse sequence, delta n. How to sketch, what is the characteristics of these basic signals. What is the second signal we discussed? It is called unit step sequence. What is the third one we have discussed? We have discussed discrete time exponential. And finally, we have discussed discrete time sinusoidal. These are the 4 basic discrete time signals we have discussed in chapter 2. Okay, so please revise what is unit impulse sequence, unit step sequence, discrete time exponential, and discrete time sinusoidal. This question, we are asked to draw unit step sequence, U of n. So U of n, what is the characteristics? This signal has a value of 1 for n greater than or equal to 0. So as you can see here from the sketch, start from n0. For positive side, all amplitudes are how much? All amplitudes are 1. For n less than 0, the negative side, all amplitudes are 0. So you can see here for n negative 1 to the negative side, all sample values are 0, right? You see here, the amplitude all are 0. So this is a unit step sequence. Similarly, you have to sketch impulse, unit impulse, discrete time exponential, discrete time sinusoidal signal. Another point we have discussed in chapter 2 is basic operations. You have to revise also basic operations on signal. Especially, you have to revise what is folding operation, okay? Folding operation, time shifting operation. We have discussed this in chapter 2, right? If a signal is given, x of n is given, folding means we have discussed it will be x of minus n, right? This case, how we are going to fold the signal, which is a reflection of a signal with respect to the vertical axis. And shifting operation, we have two types of shifting operation. X n is given. If you shift the signal towards the right, it will be time delay, so it will be n minus k. Shift the signal by a factor of k towards the right. We call it time delay. It is called what? Time delay a signal. It's called time delay. Similarly, signal, you can shift it towards the left. It will, in this case, it will, the operation will be n plus k. Okay, this operation we call it time advance. Time advance means shift the signal towards the left by k amount. It's called time advance. Okay, so before you come to the exam, please revise these basic operations. There are many operations, amplitude scaling and so on. Here we'll see the two main operations, folding and shifting. So in this question, signal is given, x of n is given. You can sketch it. So this axis is discrete time n. Okay. This is x of n. So when you do your exam, don't forget the position of the arrow, always. So x of n, the arrow here is how much? Minus 2, which means n is 0. At n0, how much amplitude? Minus 2. Okay, minus negative 2 amplitude at 0. Then this is positive side, this is on the left is negative side. So here we have positive 1, at positive n is 1, amplitude is 1. Okay, only 1 on the left side, the right side. On the left side we have 2, positive 2, which is n is what? Minus 2, amplitude is 2. What is the next amplitude? Minus 1. Minus 1. When n is minus, sorry, this is minus 1. This is minus 2. Next, we have one more sample with amplitude 3, positive 3. Time is, look here, the arrow indicates n is equal to 0, right? So this will be n is equal to minus 1. This will be n is equal to minus 2. So this will be n is equal to minus 3. On the left side, we have one sample, which is n is equal to 1. So this is our signal, given signal. So we are asked to sketch or draw these two signals. So part A, Is it time delay or time advance? This is time delay because it is xn minus 2. If it is n minus k, we call it time delay. Time delay means shift the signal towards the right by factor of how much? By factor of 2 because it is xn minus 2. So shift this whole x of n by factor of 2. So here we are asked to plot x n minus 2, okay, which means shift the signal, this signal, but towards the right by factor of 2. Part B, we are asked to sketch xn plus 1, which means time advance. Okay, xn plus 1. Here x plus plus means what? You see here xn plus k means time advance. Time advance means shift the signal towards the left by a factor of 1. Why 1? Because it is here, you can say xn plus 1. Okay, so second operation is advance, first operation is delay. So what you have to do? Shift all samples to the right by a factor of 2. So this one becomes at 3. Am I right? Because it is shifted by 2. Shift by how much? Shifted by 2. So we are not changing amplitude here. These operations are on the time axis. Okay, the amplitude remains the same. So this one amplitude remains the same, but the time n1 shifted by 2 factors towards the right. Next, the 0, at 0, how much we have? Minus 2. Again, this minus 2 shifted 2 times. So it will be where? It will be at 2. Okay. So at 2, we have amplitude minus 2. Don't change the amplitudes. We are only shift the signal towards the right by a factor of 2 times. Next, this sample at minus 1, if you shift it first to 0, then to positive 1. We are shifting it towards the right by factor of 2. So it will be at positive 1. We have amplitude 2. Okay. Next sample is minus 1 here. So we have here at minus 2. So shift it by 2, 1. When you shift it by 1, it will be a negative 1. Then shift it by 1, it will be at 0. So at 0, how much amplitude now? It becomes minus 1. Finally, we have to shift this, the last sample, 2 times. 1, 2. So from minus 3, go to minus 2, go to minus 1. So at minus 1, we have amplitude 3. Okay, so here you see where amplitudes are the same, but the whole signal is shifted towards the right by a factor of 2. Similarly, you can do this xn plus 1, which means shift each sample towards the left by a factor of 1. So if you shift all samples, minus 2, minus 1, then minus 2 time, it will be 2 amplitude, because I'm shifting all sample towards the left in this case because it is time advance. Okay, minus 1 here, minus 1 will be at minus 3, and positive 3 will be at minus 4. Okay. So you see here, all samples shifted towards the left by 1 unit. In this case, all samples shifted towards the right by 2 units. Okay, because this is xn minus 2, this is xn plus 1, shifting operation. Okay, now question number 3. Convolution sum. So as you can see here, for LTI, linear time invariant system, the output can be determined from input and impulse response. If you have these two signals, any arbitrary input x of k, in this case x of k is given here, okay? So how much x of k? 0, 2, 0, and 0.5. X of n, arbitrary input. This system has impulse response given here. So we write this vertically: 2, 1, 0, and -3. Right? Then how you are going to evaluate this convolution sum formula? As I said, there are many methods, but if you use this tabular method, it will be very easy to determine what the output of any discrete LTI system by a formula called convolution sum formula. Okay, so first we have to multiply each h of n with x of n. So 2 times 0, can you hear me? Okay, Ibrahim, you asked me. Okay, I have a question here from Ibrahim. Please, number 2A. Number 2. Which one? From chapter 1? From chapter 1, question number A, 2A, or from chapter 2? Which one, Ibrahim? Okay, chapter 1. We'll come to that. We'll come to that. Let's continue first this convolution sum. We are in chapter 2 here. So convolution sum, as you know, is very, very important equation, mathematical formula. If you have any discrete time system, if the input is given, and if you know the impulse response of the system, you can determine what? The response, the output signal, by convolution of these two. X of n input, convolution sum, asterisk indicates convolution, h of n. If you convolve these two, it will give you the output. But the system must be always LTI system, linear time invariant system. Okay, linear time invariant system. In the future, when you go to your master's, you will study a method called state space method, which is used for nonlinear systems. But here in your fourth degree, we study systems which are only linear and time invariant. But in practical case, there are systems which are non-linear. So in that case, there is another method called state space analysis method, which we will study in the master's level. Okay, when you go to your master's fourth semester, you will find advanced DSP course. So in that case, you will see state space. So don't be convolution is a method to calculate the output of discrete time system for what type of discrete time? Linear time invariant only. Okay. Now x of n is given, the input, you write it here, 0, 2, 0, minus, sorry, here is minus 0.5. That is the input. Okay. H of n, the impulse response is given. So you write vertically 2, 1, 0, minus 3. Or it doesn't matter. If you write x of n here, h of n here, if you interchange, your answer will be the same. Okay. So why x of n convolution with h of n, or h of n convolution of x of n is the same. What is this property? This property is called commutative property, right? Just like addition. Addition is commutative. If you add 3 plus 2 or 2 plus 3, the answer is the same, right? Because addition is commutative. Just like that, convolution is also commutative. It has commutative property. So if you put x of n here or here, it doesn't matter. The answer will be the same. Okay, this Zoom software, the time is limited to 30 minutes. So I will end the meeting now, and I will start it again. So you have to join it again. Okay, join again, because we have only 30 minutes